Let's begin to look at the factors determining the average plasma drug concentration, as well as the fluctuation in concentrations at steady state. First, we must realize that the time it takes to achieve steady state is totally independent of the dosage regimen. It depends solely on the drug's half-life. To understand this, think that after 7 half-lives, the original dose is basically completely eliminated from the body. So any subsequent dose simply replaces that amount of drug and doesn't lead to any further accumulation. The dosage regimen does, however, affect the average plasma drug concentration achieved, as well as the fluctuation in those concentrations during the dosing interval. First, if we look at the effect of dose, we see that higher doses lead to higher average drug concentrations as well as greater fluctuation in concentrations between doses. The average plasma drug concentration resulting from a given dose can be calculated using this equation. The higher the dose relative to the clearance of the drug, the higher the average drug concentration. Notice that the volume of distribution doesn't appear in this equation and therefore does not influence the average plasma drug concentration. Notice also that the dosing interval, represented by tau, appears in the denominator of this equation, which means that the longer the dosing interval, the lower the average plasma drug concentration. We can see how longer dosing intervals decrease the average plasma drug concentration in this graph. Notice also that the longer dosing intervals result in greater fluctuations in concentrations. The magnitude of these fluctuations can be calculated using this equation. For a given half-life, any increase in the dosing interval will result in greater fluctuations. Similarly, if the dosing interval is not adjusted for a shorter half-life, this will also lead to greater fluctuations.